तो हेलो एवरीवन एंड वेलकम टू फिजिक्स वाला गाइस। कैसे हैं आप लोग सब? होप कि आप लोग सब बहुत अच्छे से होंगे। हेलो एवरीवन, वेलकम टू फिजिक्स वाला गाइस। होप you all are doing well and your preparation is going to the up to the mark. Now guys, in the last class, first of all I welcome you all in this beautiful comprehensive course that is on signal and system, and we are starting from scratch. And in the last lecture I have covered that is we are going, means we are in between the topic that is the elementary signals, and we have covered what? Impulse signals in the last class. Now we are going to cover a real exponential, that is the exponential signals and ramp functions. Okay, now if my voice is clear, if audio videos everything is clear, then please let me know. Let me check. Hello, hello, hello. Yeah, I think my voice is clear. Okay, now let's start now. We are dealing with the elementary signals. Until now we have covered two elementary signals. One is a step function, other one is a impulse function. So what we covered in the last class was a impulse function. We have covered the impulse function. Okay, impulse function both in CDS as well as DDS. So both CDS and DDS functions are covered, and we have covered a lot of stuff like properties of impulse function, like product property, area property, approximation of a signal in terms of impulse. In the last class I told you a very beautiful property of an impulse function, which I say that impulse is a function from which we can define any other signals. Yes or no? And that is why we always use the impulse function in, that is a rigorous manner. So in LTI system you often encounter in LTI system you often encounter, that is impulse response of a function. So what do you mean by the impulse response of a function? The impulse response of a function is a response when the impulse is as an input. Okay, so that's what the impulse function is. We have covered in the last class. Now let's cover a very interesting part. One is a ramp function. So in today's class we are going to cover a ramp function, and if time permits then we will going to cover the exponential function. Exponential function, at least real I have to cover. Complex exponential tomorrow I will cover in the periodicity. So this is the topic that I am going to cover in today's class. Okay, those who haven't joined, please join as soon as possible, and please share this lecture to the maximum students. Let's start now. Let's cover the ramp function. First of all, let's discuss what do you mean by the word ramp. What do you mean by the word ramp? For example, let's consider let us consider suppose I have, this is a line. Suppose I have this straight line. Let me call this as TUT. Let me call this as a TUT. Okay, now so simple T. This is simply T. Now what I am doing is that this t. This means that we have at 1 we have this 1, at 2 we have this 2, and so on. And so on. So we have this 1, this is 2, this is 3. Suppose we have this kind of representation. At -1 we have a -1 and so on. Okay, so this should be -1, -2, and this is -1, this is -2, and so on. This is the representation of a line. What I am doing is that I am multiplying with a function which is this one. See, what will happen if I multiply both this function? What will happen if I multiply both these functions? This, you know that this is ut. This is which function? This is ut. So this is a ut. Hello Amrita. So when you multiply, see, this is only present in a first quadrant, and this is the function. This is a function which exists in first and third quadrant. So when you multiply both this function, don't you think that I will get what you will get? You will get a function. Okay, you will get a function which is this. Yes, and this I'm calling it to be, a t ut. This I am calling it to be tut. So this is the function which is represented by tut. Okay, t is multiplied by ut. In general, if I say that I have a tut, okay, I have a t into ut, I am calling this function as rt. I am calling this function as rt, and this rt I am denoting it as m, as a ramp function. This I am denoting it as a ramp function. Okay, so this is basically a ramp function. So tut is nothing but my rt, and rt I am calling it to be ramp function. Now, but this ramp function having a slope of 1, this is having the slope of 1. If you, let's say, change the slope, if you change the slope to 2, 3, 4, 5, whatever, then we call this function as, in general, we call this function as m times rt. So what is m? What is m? M is a slope. M is a slope. Okay, we call this m to be slope, and this rt is a unit ramp function. Rt is a same function, which is same. This rt is exactly the same function. So what I'm saying is that this is nothing but my m rt, which can be written as mt into ut, which can be written as mt into ut. So m is the slope of this function. Let's understand what do you mean by of the word slope. See, the slope in a very simple sense is this one. See, the slope is this one. Like this. See here, the slope is basically the angle between, that is the line making an angle on the x-axis. That's what the slope is, and this is denoted by m is denoted by tan theta. And what is this tan theta? This is equal to y2 minus y1 upon x2 minus x1. That is change in y over change in x, change in y over change in x. So for example, if change in y is 0, for example, let's consider this line. Okay, let's consider this line. Let's consider this line. If you consider this line, then here what is there? At this point, this line is having y-axis equal to 0. There is no change in y-axis, but change in x is there. Change in x is given. Change in x is finite. See, you move from 0 to some finite point on x-axis. That's what the change in x is. So for this line, we call this, if y change in y is 0, change in x is defined. So this I'm calling it to be, I'm calling this as m to be equal to 0. M to be equal to 0. But in contrast, if you see this line, this one, okay, if you see this line, then here change in y is defined, but change in x is 0. So, hello Pratiksha. So what I'm saying is that change in x is 0, change in x is 0, okay, but change in y is defined. Change in y is defined. So what I'm saying is that, listen carefully, that here m, what is m then? M comes out to be infinity. Why? See here, change in y is defined, but change in x is 0. So if change in x is 0, then 1 by 0 is nothing but my infinity. So in between, what I'm saying is, in between, if you see, if you look, then in between, the slope will increase in this way. That is what my increasing slope is. So the slope will start from 0 and it will go till infinity. So unity slope, this means that this is having the, let's say, slope of 1, slope of 2, and so on, okay? It will change in this way. So that's what the meaning of this axis. So whenever you have a infinite slope, this means that the angle, this angle is 90 degree and tan 90 is nothing but my infinity. Fine. This is what the meaning of slope is. Okay, that's what the meaning of the slope is. So if I'm saying that this is a ramp function, this is having a ramp function. So if I'm saying that I have a 3RT, what is the meaning of this? Example I'm saying. If I'm saying that I have a 3RT, this means that the representation here is like this, that this value should be 3. This is 3. This is 3. Whenever I say the word RT, listen carefully. Whenever I say that this is RT, RT means that it starts in first quadrant. It will not go beyond the first quadrant. Okay, start from 0 to infinity, because TUT is multiplied with this. Okay, so this means that slope of 3 means what? This 0 will give me 0, but this 1, if change in x-axis is 1, this will give me 3. If this is 2, this will give me a 6, and so on. That's what the meaning of nothing but a slope of 3. This is what the meaning slope of 3. Okay, so this is what all about ramp is. Okay, let's play with the ramp. So what I'm saying is that operation on ramp. Let's play operation. here. First, I am saying that I have shifted. And I will take this by example. For example, I have RT that I know that RT is this function. This is RT with a slope of 1. If suppose someone asks you YT is R of t minus 2, then you will simply say that this ramp is now shifted towards 2, shifted towards right by factor of 2. So what you will say? You will say that this would be like this one, okay, but this should be shifted by a factor of 2. This should be factor of 2, shifted by factor of 2. This was the ramp. But what is the internal meaning of this function? See here, let's take the inside representation of this function. Okay, what I'm saying is that when I say that I have R of t minus 2, then I can write it as t minus 2 ut minus of 2, with the fact that RT is TUT. RT is TUT, then RT minus 2 is t minus 2 into ut minus of 2. Now see here, what is this one? This can be written as t into u, t minus 2 minus 2 into u, t minus of 2. So let us make this function and let's feel that what is inside going, what inside is going on a certain ramp function. See, what is t? I know that the t is this one. See, this is t. That is t. And when it is multiplied with a function which is ut minus of 2, then ut minus 2 looks like this. See, this is ut minus of 2. So what will happen when you multiply both these functions? See here, before 2 everything is 0, 0 multiplied by something is 0 only. But at 2 what will happen? This is a jump. This is a jump of 1. So this jump when multiplied by this function, you will get the same function back. See, I will get having a jump at 2. What is happening is that I will get a sure jump of, see here, at 2. What is the value here? 1. But when you put t is equal to 2 here, at t is equal to 2 here, what is the value here? This is 2. This is 2. So when 2 is multiplied by this one, so this should be the value of 2. And after that, this is constant 1 and multiplied by this function. 1 multiplied by any function, you get the same function back. This means that, see here, you will get this one. This is what t into ut minus of 2 is. So what this function is? T into u t minus 2. T into u t minus of 2. Now my point is that if you subtract this function by 2 ut minus of 2, then what you will get? See here, let's take here. Okay. What I'm saying is that I will get this is 2. This is 2. And that is t into u t minus of 2. My point is that, see here, if I subtract by a function, which is 2ut minus of 2, this one, and having a jump of 2, this is a function which is 2ut minus 2, and when you subtract both this function, what you will get? See here, don't you think that this is a clamping, a down clamping of factor 2, a down clamping of factor 2 here? So what I am saying is that this function will pull down this function by the factor of 2. This function will pull down this function by factor of 2. So what you will get is this one. See, you will get exactly a same function. So that is what a tu t minus 2 minus 2u t minus 2, which is basically a rt minus 2. So whenever you see the rt, a ramp function which exists at 2, then internally these kind of operations are going on. This kind of operation, hope you understand that internally when I say simply, if I say rt minus of 2, then this is the internal operation which is going on. So I'm giving you the homework that plot, let me say homework, plot rt plus 3. You know that rt plus 3, how it's look like from minus 3. But what I'm saying is that instead of plotting this in this way, you have to feel this function in this way, that it is a t plus 3 u t plus 3. Now expand this function and plot individually and get the same function back, this one. This is the homework for you, okay? That is the homework. This is the homework that I am saying to plot here. Okay, now after that, let's start now another one, scaling. Scaling. What do you mean by the word scaling? Listen carefully. See here, the general format for scaling is yt is equal to x alpha t. This is what the general format for scaling was. But let us consider rt as xt, and I know that rt is t times ut, and this is the function. This is the function. Now my point is that, listen carefully, my point is that suppose if someone asks you that, for example, I have a yt which is x alpha t, then how will you write? You will write this as r alpha t. Okay, r alpha t, and listen carefully, this can be written as alpha t u alpha t. Hello, you can write alpha t u alpha t, alpha t u alpha t, and see here, I know that u alpha t is ut if alpha is greater than positive. You remember na, u2t, u3t, u4t, u6t, everything is ut, and u alpha t is u minus t. u minus t if alpha is negative. If alpha is negative, so u minus 2t, u minus 2t is what? U minus 2t is u minus t, simple. So this can be written as, consider, let alpha to be greater than 0. Let alpha to be greater than 0. So this can be written as yt as equal to what? Alpha t into ut. Alpha t into ut. U alpha t, I am taking it to be a ut. And this tut, I already know that is RT. Tut, I already know it is RT. It is alpha times RT. This means that, listen carefully, when you scale this factor, when you scale this function x of t, then the r alpha t is basically alpha RT. So whatever the scaling factor will come into the as a coefficient. So what I'm saying is that this will change the slope of this function to alpha. This will change the slope of this function to alpha. That's what the very, very important point was. So if suppose someone asks you that what is r of 2t, it is basically 2rt. Otherwise, if you simply say r2t, then on scaling, see here, this is rt, that's what rt is, and then this is 0, this is infinitive. How to scale a function? Simply divided by 2, simply divided by 2, simply divided by 2, and it will not change the point. It will not change the point because 0 divided by 2 is 0, infinitive divided by 2 is infinitive. It will not change the point. So straight away this point will not change. But what is changed is the slope. Slope will also be changed. Slope of this function is not 1, but slope of this function is nothing but my 2. So whatever be the scaling factor will come into the ramp of this function. For example, let us take combined operation. Let us take combined operation. Combined operation, if I say, then suppose I have a yt which is r of minus 3t plus 9. Suppose someone asks you that plot this function, r of minus 3t plus 9. How will you plot? Simply take r to be minus 3 common, and this is t minus of 3. Now start with ramp. Start with ramp. This is a ramp. What it will take? It will change the slope. It will change the scaling factor is minus 3. It will change the slope. First it will reverse it. And then it will change the slope to minus 3. This is minus 3. Mind it that the slope earlier was 1, but now it is a minus 3. And now you have to shift this factor towards right by factor of 3. This means that this is a function which I am calling it to be this function. See? Okay. So what is the limit of this function? Minus infinitive to 3. The limit of this function is minus infinitive to 3. This is what and with a slope of minus 3. The slope can easily be found by taking the coefficient of this factor. Whatever be you have a alpha will be taken as a slope of this factor. Here earlier the alpha was 1, here the alpha was 1. Listen carefully here. If I am saying this one, alpha was 1. See, t coefficient is 1. If you have alpha, then the scaling factor means the slope of this factor will change by alpha. This is what the important point is. I am giving you homework that, again homework, plot are t by 3 minus 1 by 4. And tell me that what should be the scaling factor. Let's consider some value also. Here, let's consider it to be a 3. 3 are t by 3 minus 1 by 4. I want this to be a what? Plot it. So this plot you have to find out. This is the homework for you. Second homework of today's class. Okay. Fine. So till now we have that is made some fundamentals for a ramp function. Let's play further with the ramp. What I'm doing is that, see here, let's say that I have this function. Okay. See here. Very good evening, 𝐂𝐤𝐧𝐤𝐬. What I'm saying is that, see here, suppose I have a points, some points I'm marking randomly. Let's say call it to be -3, call it to be -1, call it to be 1, and call it to be 3. Very good evening, 𝐁𝐚𝐿. Now, see here, what I'm saying is, listen carefully. Suppose I am starting a one ramp, okay? I am starting a one ramp which is having a slope of, let's say, 3. Thank you. Thank you, 𝐁𝐚𝐿. So what I'm saying is that, see here, this is a ramp which started from -3 and it will go on till infinity. If no one stops, this ramp, then this ramp will continue its journey till infinity. What I'm doing is that, see here, at -1, let's take that another ramp of negative what? Negative -3 slope. I am adding a negative of -3 ramp at -1. Now tell me what happened to this line. See here, what happened to this line? See, listen carefully now. See here, up to -3 to -1, listen carefully, -3 to -1, no one stops this ramp. So this ramp will continue its journey till -1. The ramp will continue its journey. Let's change the color. Okay. The ramp will continue its journey. Till -1 if no one stops it. But at -1, since -3 slope is added into it, so what will happen? This -3 and this +3 and this -3, okay, will meet and makes a 0 slope. And I told you in this one, see here, if I have a 0 slope, then I have a line parallel to x-axis. If I have an infinitive slope, then I have a line parallel to y-axis. This means that, see here, after this one, don't you think that I will get a I will get a 0 slope line. So this line is having a 0 slope. Now suppose, for example, at -1, what I am doing is that again I'm adding, sorry, again I'm adding a ramp which is of having a -3 slope, which is having a -3 slope. Now tell me what happened to this line then? What happened to this line? Mind it, the line will now change its journey, okay? Change its journey in the negative direction. And it will go on, go on, go on like this, go on like this, till, suppose if I add a +3 slope here, a +3 slope here, +3 slope here, then what will happen to this line? See, from 1 to 3, this line is having a -3 slope. But this -3, when add with this +3, becomes a 0 slope, and hence I will have a line which is nothing but my, this one, see? This one. You understand my point or not? See here, by introducing a 4 ramp, one is this one, one is this one, one is this one, and one is this one. By introducing this 4 ramp, I can make what? A beautiful trapezoid function. A beautiful trapezoid function. So this trapezoid function I can get from this combination of this 4 ramp. So how will you write? Let's consider this as to be xt. Then what you will say, xt is, start from here. See, this is the line, this one, first one. It is 3r t plus 3. 3r t plus 3. Now this line comes at -1. This means that plus minus of 3r t plus 1. Minus of 3r t plus 1. Okay. And at, so now after that what will happen? This line becomes 0 slope. Now to change the direction in downward, what you have to do? Plus minus 3r t minus 1 minus r 3 t minus of 1. The direction is downward. Now to stop it at 3, what I am doing is that plus 3r t minus of 3. And this 4, okay, will what? This 4 will gives me forgive my drawing, it's okay. This 4 will gives me, let me change the color. This 4 will gives me a what? A basic trapezoid function. This is what a formation of nothing but my trapezoid from ramp. Similarly, we can find out, for example, let's consider this one. Let's consider this one. See here. Suppose I have this function and this function, and what I am doing is that, see here, what I am doing is that again I am adding a 3 different ramp at 3 different points. 3 different ramp at 3 different points. So one point is at, let's consider this to be one point as -3. This is 0 and that is 3. This ramp is having a +2 slope. This ramp is having a -4 slope. And this ramp is having +2 slope again. Okay. Hello. This ramp is having +2 slope again. Now tell me what happened to this line. See here, listen carefully. This line will go on with a +2 slope. If no one stops, then this line will continue till infinity. But what will happen at this point? See, at +2, at 0, what will happen? This +2 becomes a -4. Yes or no? This +2 becomes a -4. This means that the line will change its direction with a slope of 2, and it will continue till 3. At 3, this is having a -2 and this is having a +2. -2 plus 2 will become a 0. And don't you think that I will get what? I will get a very beautiful line up to this. See? This one and this one. Forgive my drawing. This one. So this is having a -2 slope. So how will you write this xt? Let's consider this to be xt. Then I will write this xt as, see, I have 3 basic ramp function. One is this one, another one is this one, another one is this one with finite slope. With finite slope. So what I will write? I will write this xt as what? Let's start now. This is 2r t plus 3 minus 4r t and plus 2r t minus 3. And this is what a beautiful triangle is. A triangular function which is represented by this one. See? Easily you can write. So this is a pure ramp and pure step combination. I have pure ramp combination I have, and I made a 2 different signals. One is a trapezoid and other one is a triangle. Let's combine these ramp and step, and let's see that what kind of function I will get when I combine both this. When I combine both these functions, let's do it. So what I'm doing is that, see here, let's say, suppose someone asks you that I have this function. Write the elementary representation of this function. So this is having a slope of minus, let's say value -6. This is 0 and that is 4, and this value is 2. Consider it to be 2. Write elementary form of xt. This is what my xt is. Write the elementary form of xt. Let's do it. See here, for this function, for these kind of signals, you must recognize that what kind of elementary signals are present in this one. See, this is ramp and that is jump. This is a ramp with having a 0 slope. Ramp with 0 slope. With 0 slope. Okay. Now my point is that, tell me that what is the slope of this line? What is the slope of this line? The line changes here. Slope is defined by m is delta y over delta x. Change in y over change in x. See here. Change in y is 2, change in x is 6. This means that this is having, since this line is going towards +1, so this should have a 2 by 6, 1 by 3. This is having a +1 by 3 slope. Now +1 by 3 slope is going on, and at the point 0, +1 by 3 becomes a 0 slope. And this continues till 4, but suddenly a jump comes. And this changes the line to the jump to nothing but my 0. How you will write? See, x of t can be written as, first write 1 by 3 of r t plus 6, and this will go on till this one. See, this will go on till this one, and then you have to cancel this ramp, so this should be minus 1 by 3 with the same, you have to make it 0 slope. So if earlier slope was plus 1 by 3, to make it 0, what you will do? Minus 1 by 3 at rt. Now by joining these two, I am made a function which is having a 0 slope, and then this is having a jump of how much? See, look at the value here, 2, and 2 becomes a 0. This means that it is minus 2 u t minus 2 u t minus of 4. This is what the one of the most important representation of this function is. So this is what my xt is. Simple, very simple. Xt can be represented in this way. Let's take a further complex one. Let's take further complex one. Okay, let's do it. This kind of function, or some different one. Let's mark it. This is minus 6, this is minus 4, that is 0, this is 4, that is 6, that is 8. This value is, let's say, 8. This value is 12, and this value is 16. After that, I don't think that any value is needed. Okay, I'm giving you 2 minutes. Question is that write the elementary representation of t. Let's call this as x. Do it. Do it, please. Giving you 2 minutes. Come on. Everyone must do it. Yes. Come on, let's start. See here. This is jump. This is jump of how much? This value is 8. 8 minus 0 is 8. 8 jump we have. After that we have a 12 jump. That's right now. See here. X of t can be written as, see, at minus 6 we have a 8 jump, means 8 u t plus 6. 8 u t plus 6. Now at minus 4, this 8 jump becomes a 12 jump. So this means that on 8 you add something. What you have added? Plus 4 u of t plus 4. Plus 4 u of t plus 4. At minus 4 you have added the plus 4. Now but here is a slope. Here is a slope we have. Let's find out the slope of this line. First, see here, this is 12. So no. Yes, this tip is needed, yes or no? Because without that, I don't think that I will get the value. Let's call this tip to be sustained. This tip is needed. I think so. That tip is needed because this value is 12. This value should be sustained. Yes. Now tell me that what is a gap between these two one. Let's find out the slope of this one. See, x-axis gap I know. X-axis gap I know. This is the x-axis gap. See, from here to here. This is what my x-axis gap is. And y-axis gap is here to here. Y-axis gap is from here to here. So y-axis is, what is the slope? Slope m is delta y over delta x. Change in y is 12. This should be 12. And tip is 16, so this should be 4. 16 minus 12, 12 4 16. And what about this one? 4 divided by 4. So let's write the slope here. Slope is plus 1. Why plus? Because it is going towards plus infinitive. What about the slope of this one? See here, this is 0, 4 again and 12, 4 again. This is having a slope of minus 1. Let's quickly find the slope here also. So this changes 8, this changes 2. Look, this changes 8, this changes 2. So this should be having a minus 4. Slope is minus 4. What about this jump? This jump is 12 becomes 8. Means this jump is minus 4. Jump is minus 4. This is having a 0 slope. Everything is now written. This is slope. This is slope. This is slope. This is jump. Yes. Now tell me, let's start from at minus 4. What will happen? See, at minus 4, the ramp starts with a slope of plus 1. So this should be plus r t plus 4. But at 0, what will happen? This ramp change its direction to having the slope of minus 1. Having the slope of what? Minus 1. This means that this should be minus 2 r t because this happens at 0. Now this is having a slope of minus 1. But minus 1 slope, listen carefully what happens at 4. Listen carefully what happens at 4. Let me change the color. What happens at 4? Two things happen. First of all, this slope becomes a 0 slope like this. See, the slope becomes a 0 slope. But you do not let this line to move forward. You jump it by a minus 4 jump so that the level of this line is not 12, but it is 8. This happens at 4 itself. So at 4, first of all, you have to cancel the ramp to make a zero line, zero slope line, line parallel to x-axis, and then you suddenly jump it to be minus 4. Means what will happen? See, what will happen here? What is happening is that, see, at 4, first of all, I will have, see, that slope is minus 1. Now, this is plus 1, minus 2, minus 1. This should be plus 1 RT minus 4. But it's okay, RT minus 4. It will becomes a line parallel to x-axis. But now what I am doing is that instead of going forward, I am jumping from 12 to 8. This means that it is a minus 4 UT minus 4. Now then the line will go up to this one. The line will go up to, let's say, 6. This is 6. Now from 6, I have again a minus 4 slope. From 6, I have again minus 4 slope. This means that I have minus 4 U, not U, R. R R T minus 6. But if you do not slope this, do not stop this line will go like this. But you have a stop, that is, you make it to be 0. How will you make it equal to 0? Minus 4, if you add plus 4 slope line at 8, then this should be plus 4 R T. And now this is completed. So two things you have to take care of. One is this one and one is this one. At this point, at 4, what is happening is that two things happening. One, the line cancelled and there is a jump. And at 8, this slope cancel out. So it is same as trapezoid that we have covered. The same section that we have covered, trapezoid. So this is what the elementary representation of this function is. This is what the elementary representation of this function is. Let me give you the homework for this one. Let's take one more. That was a gate problem. Gate problem must look at the very lallu problems. See here? This is 0, that was 2, that was 4, that was 8, that was minus 6. Write the elementary form, giving you again 2 minutes. That was, I think, they will ask for find the Laplace transform of this function. Laplace transform easily can be find out if you find out the elementary form of this function. Once elementary form of this function is done, then easily you can find out the Laplace transform of this function. Come on. Yes, easily can. See, first in the same situation. This is a line, but it is followed by jump. Mark it as a hook. Line followed by jump, we have to cancel the ramp. That's what the point is. So line followed by jump, we have to cancel the ramp. Do it. Let's mark here. Next. First, find out the slope of this line. What is the slope? Change in x is, change in y is 8, change in y is 8, change in x is 2. So this means that 4. This is having a 4 slope, plus 4. 4RT, it will go on. But what will happen at 2? It first cancel to 0, and now you have a jump. See, you have a jump. How much jump? See, at 2, what is happening? First you cancel this, minus 4RT minus 2. Now this is a line parallel to x-axis. Tell me what is the jump? See, what is this value? 8. And where you have to go? Minus 6. Upper value is minus 6, lower value is 8. This means that this should be minus 14. U t minus of 2. Why minus 14? See, this is 8, na? Tell me what I have add to 8 on 8 to get minus 6. So first subtract 8 becomes minus 0, and then minus 6. 0 to minus 6. This is 6. This is 8. 6 minus 8. 6 minus 6 minus of 8 is minus 40. Now this is having the jump of 6. Minus 6. Now to make it 0, we have to add plus 6 ut minus 4. This is what my elementary form of this function, very lallu problem. Okay, so easily you can find out the elementary form of any function, any function. Okay? One hypothetical kind of elementary function I am giving you as a homework. Make. Let's take. So yeah, and there is a one label, this one. There is another label, this one. There is another level, this one. Any other level is needed? This is same line, okay? I don't think that it is needed. So this should be 0. This should be, let's say, 8. Let's call it to be 16. And let's call it to be 32. Everything here is 8. Everything here is 16. Everything here is 32. I don't think that any other level is needed. This should be level. Minus 16. This is minus 12. This is minus 4. This one. This should be 0. This is 4. This is 8. What is 8? This one is 8. Okay. This is 10. Let's call it to be 12. This is 16. And that should be 20. Homework. Any other level, if you require, then please assume to make it complete. Just a hypothetical comes in my mind, so I have drawn it. I don't think that there is an error, but if there is an error, human mistake, then please assume the point by your own. Concept is important, right? Elementary form of 𝐿𝐻𝐷. This is what my 𝐿𝐻𝐷. Okay, this is the homework that I am giving you. Okay, and with this, I think that complete ramp is over. Now, exponential, if I start, then only 15 minutes is left. So I don't think that I am able to complete this one. So we will cover exponential in next class itself. And we will cover exponential as a whole. That is, real exponential I will cover in half an hour. And then the remaining 1 hour, I will cover about the periodicity of a signal. So another topic is the characteristics of a signal from the next class onwards. But we will cover the exponential in real exponential in tomorrow's class. Okay. So with this, I think that everything is clear. Everything is covered. Okay. And what we have covered is a ramp function. We have covered ramp function. First, we covered the elementary form. Then we have covered operations. We have covered these two things. Okay, form. And please go and revise all the ramp concepts which is required for your gate preparation. Okay, and with this, thank you very much. If you have a doubt, then do ask the doubt. Okay, in my Telegram channel, if I think in description box it is written, Pankaj Singh sir, control system and signal system. This is what I think Telegram channel. And with this, thank you very much. Thank you. If you have a doubt, then surely I will wait for another 20-30 seconds. Thank you very much.